Hello, good morning students. So today I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class, that is inverse circular function. So today also I am continuing the same topic, that is inverse circular function, right? So this is your continuation part. So now today we will do questions from higher secondary question papers, that is WBCHSE, that is West Bengal Council of Higher Secondary Education. Is that clear? So we will do questions from higher secondary question papers. Okay, so we have almost completed the problems from the book of XII, right? So this question is from HS 2015. So the question number is 2A number 2. Prove that tan inverse 1 upon x plus y plus tan inverse y upon x square plus xy plus 1 is equal to cot inverse x. You have to prove this LHS is equal to RHS. Okay. So this question carries 4 marks, right? So this question carries 4 marks. So let us write down the left hand side. So what is the left hand side out here? It is tan inverse 1 upon x plus y plus tan inverse y upon x square plus xy plus 1, right? So which formula is used in this case? It is tan inverse x plus tan inverse y, right? So let us use the formula. So now you know the formula, x plus y, tan inverse x plus y upon 1 minus xy, isn't it? So let us write down 1 upon x plus y plus y upon x square plus xy plus 1. This is your x plus y. So whole divided by 1 minus, what is x in this case? 1 upon x plus y, right? What is y in this case? Y upon x square plus xy plus 1. So here the bracket is closed. So this is tan inverse x plus y upon 1 minus x into y. Is that clear? So let us get the LCM in both the numerator as well as in the denominator. So which is equal to tan inverse. So what's the LCM in the numerator? It is x plus y into x square plus xy plus 1. Right? So this is the LCM, x plus y into x square plus xy plus 1. Alright? So now, this LCM is divided by x plus y. So x plus y gets cancelled. You will get x square plus xy plus 1 plus. Now again, this LCM is divided by x square plus xy plus 1. That means, which factor will be cancelled? X square plus xy plus 1 factor will be cancelled. So what do we get? X plus y only. So it is multiplied by the numerator, that is y. So that is y into x plus y. Is that right? So next, in the denominator also, what's the LCM? It is x plus y into x square plus xy plus 1 is the LCM. That is, the LCM is both these factors, that is x plus y into x square plus x square plus xy plus 1. That is x plus y into x square plus xy plus 1 is the LCM. Both these factors will be the LCM. So what is there? What is here now? It is x plus y into x square plus xy plus 1. So what will be the expression about this denominator? That is, you will get x plus y into x square plus xy plus 1. Okay? Then minus, now this LCM is divided by x plus y into x square plus xy plus 1. That is only 1. So 1 into y is y. So here second bracket is closed. Is that clear to all of you? So you can cancel here x plus y. You can cancel these LCM. Is that right? So which is equal to tan inverse. So within bracket, let us multiply here. Okay, the first three terms are x square plus xy plus 1, then plus xy plus y square whole divided by, in the denominator also you have to multiply these two factors first, right? X into x square, this is x cube plus x square y plus x square y, then plus x, right? Then comes plus, what is y into x square? It is x square y, right? Then plus xy square plus xy square, xy into y is xy square plus y, and then the last term is minus y. Since there is no space there, we will write it in the next step, that is minus y, right? So that is minus y. Is it clear to all of you? So now let us simplify the expression within first bracket. So here plus y minus y gets cancels. So is equal to tan inverse. So within bracket, what do we get? It is x square, right? Plus xy plus xy. Same sign, similar terms can be added. Plus 2xy, then plus y square plus 1. This whole divided by. So whole divided by, what can you write now? You can write here x cube, right? Then x square y plus x square y. Same sign, similar terms can be added. Plus 2x square y plus 2x square y. Then write down plus xy square. Then the last term is x. So is the simplification clear now? So let's simplify once again. So in the denominator there is a common. What is that common? That x is common out there. So which is equal to tan inverse. So within second bracket, right? So numerator remains same, that is x square plus 2xy plus y square plus 1. This whole divided by, in the denominator also x is common, right? So x within bracket x square plus 2xy plus y square plus 1. So in the denominator x is taken common. So second bracket is closed, right? So now what will you do in the next step? So you can cancel the similar terms out there in both the numerator as well as in the denominator. Okay? So here you can cancel this. That is, it is divided. Right? So now, what will you write in the next step? Is equal to tan inverse. So within bracket, what do we get? It's only 1 upon x. So it is simplified. So by formula, what is tan inverse 1 upon x? Cot inverse x, isn't it? So it is cot inverse x. So which is equal to right hand side. So I think you have understood this problem. So copy it. We'll do the next question from HS question paper. Okay. So now we will do the next question. That this question is from Higher Secondary 2017. Question number is 1A number 2. So this question carries 2 marks, right? So let us evaluate it. Evaluate means you have to find out the value of the given inverse circular function. So what is the given inverse circular function out here? It is sec square within bracket tan inverse 2 plus cosec square within bracket, it is cot inverse 3. Okay. So now is equal to, you can write it within whole square, isn't it? Like if you have sec square theta, so you can write it within whole square, that is sec theta whole square. So likewise you can simplify it here also. So within second bracket sec within first bracket tan inverse 2 whole square, right? So similarly you can write down the second term, that is within second bracket it is cosec within first bracket cot inverse 3 second bracket closed whole square. Okay. So now let us find out the value for sec tan inverse 2. You can easily simplify it. Now you should know the method how to get the value for sec within bracket tan inverse 2, right? So first term. So first term, that is let sec within bracket tan inverse 2 is equal to, not sec, sorry. Suppose here the first term is, what is the first term? Here the first term is sec tan inverse 2 second bracket close whole square. So let us find out the value for sec tan inverse 2. So let us assume tan inverse 2 is equal to theta, right? So when this tan inverse goes to the right hand side, it becomes tan. So it is tan theta is equal to 2. Okay? So now you have to get the value for sec theta or sec theta whole square. So this first term now becomes, so first term is equal to sec. Now what is tan inverse 2? It is theta. This is your whole square, which is equal to, this is your sec square theta. Now you can convert this sec square theta in terms of tan, isn't it? What is sec square theta in terms of tan? You know that it is 1 plus tan square theta, which is equal to 1 plus tan square theta. Okay? So what is the value for tan theta here? It is 2. So is equal to 1 plus, this is your 2 whole square, 1 plus 4 is equal to what? 5. So what is the value of the first term? What is the value of the first term here? What is sec tan inverse 2 whole square? It is 5 only. Is that clear? So similarly you can simplify the second term. So therefore what is the second term out here? What is the second term here now? Cosec cot inverse 2, cot inverse 3, cosec cot inverse 3, this is whole square. Similarly as in the first term, you can simplify the second term. So how can you simplify it? Let us assume cot inverse 3 within bracket as beta. Don't write it as theta because in the first term we had already assumed tan inverse 2 as theta, right? So let cot inverse 3 is equal to what? Beta. Now cot inverse goes to the right hand side and it becomes cot, that is cot beta is equal to 3, right? Now what is the second term now? What is the second term now? Which is equal to, this is cosec, what is cot inverse 3? It is beta. This is your whole square, that is cosec beta whole square. So what do we get? It is cosec square beta. So you know the formula of cosec square beta in terms of cot beta. So you have to write cosec square beta in terms of cot beta because we know the value for cot beta which is equal to 3. Okay. So what is cosec square beta? It is 1 plus cot square beta, right? So next, which is equal to 1 plus, what is the value for cot beta? It is 3. So this is your 3 whole square, which is equal to 1 plus 9 is equal to, what is the value of the second term? The value of the second term is 10. Is it clear? So now you have to get the value of the given expression, isn't it? So what is the given expression out here? The given expression out here is this one. Okay. So let us write down this given expression. Therefore, sec square tan inverse 2 plus cosec square within bracket, it is cot inverse 3, which is equal to, now what was the value for this sec square tan inverse 2? It was 5. It was 5 plus, what is the value for cosec cot inverse 3 whole square or cosec square cot inverse 3? So it is only 10. What is 5 plus 10? Which is equal to 15. So this is the answer. So this is very, very important question. You can practice it at home. Okay. So I think you have understood it. So let's do the next question now. So now we will do next question from Higher Secondary 2000 18, right? The question number is 1A number 2. This also carries 2 marks. This also carries 2 marks, okay? So 1A number 2 question is, if sine inverse x is equal to tan inverse y. So this is your given equation. You have to prove that 1 upon x square minus 1 upon y square is equal to 1. That means you have to eliminate sine inverse and tan inverse from both these sides, from LHS as well as from RHS. Okay. So how can you eliminate here? Now since there is sine inverse x is equal to tan inverse y, and you have to prove 1 upon x square minus 1 upon y square. That means you should get 1 upon x, 1 upon y like that. Okay. So what we will do here is, let us write it in terms of 1 by x. If you want to write it in terms of 1 by x, you have to convert this into cosec inverse, isn't it? So which is, or cosec inverse, this is your 1 by x is equal to, let us write this one also in terms of 1 upon y. So you should convert into cot inverse. That is cot inverse, this is your 1 upon y. Is that clear? So now this is cosec inverse and this is cot inverse. So now either you have to change cosec inverse into cot inverse, or you may change cot inverse into cosec inverse. Okay? Either you have to change cosec inverse into cot inverse or cot inverse into cosec inverse. Only one of the terms should be changed. Okay? So let us change this cot inverse in terms of cosec inverse. Okay? So let cot inverse 1 upon y is equal to what? Theta. Or what is the value for 1 by y? 1 by y is equal to cot theta. That is, we get the value for cot theta, which is equal to 1 upon y. Okay? So since we are changing this cot inverse into cosec inverse, so you have to write down the formula for cosec square theta, isn't it? So therefore, what is the formula for cosec square theta? Which is equal to, what is the formula for this cosec square theta? It is 1 plus cot square theta. Is that clear? So that you can use the value for cot theta here, right? Or cosec square theta is equal to 1 plus, what is cot theta here? 1 by y. So it is 1 by y whole square. Right? Is that clear? So, or cosec square theta, is equal to 1 plus, this is 1 upon y square. Okay? So what is the value for cosec theta now? So cosec theta is equal to root over 1 plus 1 upon y square. So let us get the value for only theta. Okay? That means this only cosec should be taken to the right hand side. So it is theta is equal to cosec inverse root over 1 plus 1 upon y square. Is that correct? I think you have understood it. Now let us put this value of theta. What is the value for theta actually? Actually theta was assumed as cot inverse 1 upon y. That is cot inverse 1 upon y is equal to, it is cosec inverse root over 1 plus 1 upon y square. So just now we get the value for, what? Cot inverse 1 upon y, right? So what is the value for cot inverse 1 upon y? Is equal to cosec inverse root under 1 plus 1 upon y square. Okay? So let us write down this given again. So write down, your given is sine inverse x is equal to tan inverse y. This sine inverse is converted into cosec inverse 1 upon x, and this tan inverse y is converted into cot inverse 1 upon y. Okay? So just now we got the value for cot inverse 1 upon y there. Just put the value now. So you can put the value for cot inverse 1 upon y here. Okay? So what is the value for cot inverse 1 upon y? It is cosec inverse within its square root 1 plus 1 upon y square. Okay? So let us keep the left hand side same. That is cosec inverse. It is 1 upon x is equal to, what is there on the right hand side? It is cosec inverse root over 1 plus 1 by y square, right? So now what will you do in the next step? From both the sides you can cancel that cosec inverse and we get what? Don't write cosec inverse in the next step. So what do we get? 1 upon x is equal to root under 1 plus 1 upon y square, right? So now from here, can you prove that required result? What is the required result here? 1 upon x square minus 1 upon y square is equal to 1. That means you can square both the sides here. Write out squaring both the sides. Squaring both the sides. So what do we get squaring both the sides? 1 upon x square is equal to, on the right hand side, square root whole square, isn't it? So what is square root whole square? That is, square root will be removed. So what do we get? 1 plus 1 upon y square. Is that clear to all of you? Now we can take 1 by y square to the left hand side and we can get the required result. Okay? So let us take 1 upon y square to the left hand side. So it is 1 upon x square minus 1 upon y square, which is equal to 1. So it is proved. Right? So it is done. Understood this one? So you can copy it. Let's do the next question now. So now we are doing the next question. This question is from same HS question paper, that is 2018, right? But the question, this question carries 4 marks, right? That is question number 2A, number 2. You have to prove that. So what is to be proved here? You have to prove that tan of within bracket pi by 4 plus half cos inverse A by B plus tan within bracket pi by 4 minus half cos inverse A by B is equal to 2B upon A. You have to prove LHS is equal to RHS. Okay? So let us write down this left hand side again. So we have written down the left hand side. So you can copy it also. So to make it more easier, to make this problem more easier, let us assume this half cos inverse A by B as theta, right? To make this problem more easier, let us assume this half cos inverse A by B as what? Theta, right? So let, this is half cos inverse A by B is equal to what? This is theta. Is that clear? So now cross multiply by 2 here. Let us simplify it. So cos inverse A by B is equal to what? 2 theta. Okay? Or A by B is equal to what? It is cos 2 theta. Now cos inverse goes to the right hand side and becomes cos 2 theta, right? So what is the value for cos 2 theta here? So cos 2 theta is equal to A upon B. So we have got this value. That is cos 2 theta is equal to A by B. Let us write it here. Because after some steps, we may write cos 2 theta is equal to A by B. That's why I have written on the rough. Okay? So you have to use that cos 2 theta is equal to A by B. Okay? Now this left hand side now becomes, so this LHS now becomes is equal to tan of within bracket, it is pi by 4 plus, so we have assumed half cos inverse A by B as what? Theta plus again tan of within bracket, this is pi by 4, then minus this is theta. Is that clear now? So I think you have understood it. Okay? So now let us simplify it further. Okay? So now you can use the formula from compound angle in trigonometry. You did tan of A plus B, you did tan of A minus B, isn't it? So let us use the formula of tan of A plus B out here. Pi by 4 is taken as A and theta is taken as B. So what is tan of A plus B out here? It is tan pi by 4 plus tan theta, this divided by, and in the denominator, what can we write? In the denominator, 1 minus tan A tan B. Is that clear? Plus, similarly, what is the formula for tan of A minus B? So what is tan of A minus B? Tan A minus tan B whole divided by 1 plus tan A tan B, right? So you can use this formula here also. So it is tan pi by 4 minus tan theta divided by 1 plus tan A tan B, that is tan pi by 4 and tan theta. Is that clear? So now pi by 4 is the standard angle. So what is the standard value for tan pi by 4? It is 1. So you can write here, which is equal to 1 plus tan theta divided by 1 minus tan theta plus. Next, what is tan pi by 4? 1 minus tan theta divided by 1 plus, again, this tan pi by 4 is always 1. So 1 into tan theta is always tan theta. Is that clear? So now let us simplify it. So let us simplify it now. You can get the LCM now. So what is the LCM of 1 minus tan theta and 1 plus tan theta? These are the LCM, isn't it? That is 1 minus tan theta into 1 plus tan theta. Themselves are the LCM. Okay. Now this LCM is divided by 1 minus tan theta. 1 minus tan theta will be cancelled. So it remains 1 plus tan theta. Should be multiplied by the numerator. These are same factors. If you multiply the same factors, you can write 1 plus tan theta whole square. Right? Then comes plus sign. Clear? Now again this LCM is divided by 1 plus tan theta. So 1 plus tan theta gets cancelled. You will get 1 minus tan theta. And this 1 minus tan theta should be multiplied by 1 minus tan theta. That means both are same. What is the product? 1 minus tan theta whole square. Is it clear to all of you? So now let us simplify it. Is equal to, now which formula is used in the numerator? Which formula is used now? This is a plus b whole square, isn't it? That is 1 plus tan theta whole square is a plus b whole square. And what's about 1 minus tan theta whole square? It is a minus b whole square. So you know the formula, right? What is a whole square? 1 plus twice ab. What is twice ab? 2 tan theta plus what is b whole square? Tan square. You know how to simplify it, isn't it? So plus, what is a minus b whole square? A square minus 2ab plus b whole square. So it is 1 minus twice ab minus 2 tan theta plus b square is tan square theta. Whole divided by, in the denominator, what is the formula? A minus b into a plus b. What is the formula? A minus b into a plus b. It is a square minus b square. So it is 1 whole square minus, what is b whole square? It is tan theta whole square. Is that clear to all of you? So I think you have understood it. It's just a simplification, right? So 2 tan theta minus 2 tan theta gets cancels. So 1 plus 1 is 2 plus tan square theta plus tan square theta, that is 2 tan square theta whole divided by, it is 1 whole square 1 and tan theta whole square is tan square theta, right? So next, what will you do? You can take 2 common here. So is equal to 2 is taken common within bracket. 1 plus tan square theta divided by 1 minus tan square theta. 1 minus tan square theta. Okay. So there is a formula there. Cos 2 theta. What is the formula for cos 2 theta in terms of tan? Cos 2 theta is equal to, you know, 1 minus tan square theta upon 1 plus tan square theta. So you can take this 1 plus tan square theta, 1 plus tan square theta to the denominator. So it goes below 2 divided by, it goes below 1 minus tan square theta, isn't it? 1 minus tan square theta divided by 1 plus tan square theta. As you know that the formula for cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Is that clear? So which is equal to 2 by, what is the formula in this case? It is cos 2 theta. So now in the previous step, we had got the value for cos 2 theta that we had assumed, isn't it? That is, we had assumed half cos inverse a by b is equal to theta. Then 2 theta cos is equal to cos inverse a by b. So cos 2 theta is equal to what? A by b. So 2 upon cos 2 theta was a by b. You can check it. Cos 2 theta is a by b, which is equal to, what is the answer? Now you can get the correct answer on the right hand side, isn't it? So a by b, when it goes up in the numerator, becomes b by a. You know that, isn't it? So it is 2b upon a. Is that clear? So this is your answer. Proved. So we have got 2b by a, which is on the right hand side. So this is also very important question. You can practice it at home. So you can copy it now. Let's do the next question. Okay. So now we are doing problem from HS 2019. Okay. So this number is 2a, number 2, and this question also carries 4 marks, right? So if tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2 and x plus y plus z is equal to root over 3, then you have to show that x is equal to y is equal to z. So there are 2 conditions given. So 2 conditions are given out here, right? So tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2. This is the first condition given. What is the second given condition here? X plus y plus z is equal to root 3. So using these 2 conditions, you have to prove that x is equal to y is equal to z. Is the question clear to all of you? So okay, let's start this question. Solution. So first one given is, your given is tan inverse x plus tan inverse y plus tan inverse z equals what? It is pi by 2, right? So let us eliminate tan inverse from here. So there are 3 terms on the left hand side. You can take one of these 3 terms. You can take one of these 3 terms to the right hand side, and on the right hand side there should be only 2 terms, so that you can use the formula of tan inverse x plus tan inverse y, right? So let us take tan inverse z to the right hand side, right? You can take also tan inverse x to the right hand side, or you may take tan inverse y, you may take tan inverse z, okay? So any one you can take to the right hand side. So let us take tan inverse z to the right hand side. So keeping tan inverse x plus tan inverse y on the left hand side, right? So which is equal to, this is pi by 2 minus tan inverse z. Is that clear? Next, what is the formula on the left hand side? It is tan inverse x plus tan inverse y, you know that. So what's the formula out here? It is tan inverse x plus y upon 1 minus xy, which is equal to pi by 2 minus, this is your tan inverse z. Is it clear? Now let us take this tan inverse to the right hand side, okay? So or x plus y divided by 1 minus xy is equal to tan of, within bracket, pi by 2 minus tan inverse z. So when this tan inverse goes to the right hand side, it becomes tan. You know that, isn't it? So now, what is tan 90 minus theta? You know that this is cot theta, right? You have done it in class 10. What is tan 90 minus theta? It is cot theta. But what is theta out here? It is tan inverse z. So or it is x plus y upon 1 minus xy is equal to, what is tan 90 minus theta? It is cot theta. So this will be cot, within bracket, it is tan inverse z. Is that clear? That is tan 90 minus theta, here is tan inverse z. So what is cot theta? It is cot, within bracket, tan inverse z. Okay. So or x plus y divided by 1 minus xy is equal to, now you should convert tan inverse into cot inverse. You know how can you convert? You know how to convert cot inverse into tan inverse, or sorry, you have to convert tan inverse into cot inverse. You know how to convert tan inverse into cot inverse, right? So it is cot, within bracket, cot inverse, this is 1 upon z, right? So what is cot inverse 1 by z? Only you can write 1 by z. That is cot inverse will be cancelled. So or x plus y divided by 1 minus xy is equal to 1 upon z. Is it clear to all of you? Now let us simplify it. Let us cross multiply it. Xz plus yz is equal to, what is here? It is 1 minus xy, right? So let us take that minus xy to the left hand side. So or it is xy plus yz plus zx is equal to what? It is 1. That is, we have got the value for xy plus yz plus zx, which is equal to 1. So let us mark it number 1. So we have got this condition number 1, that is xy plus yz plus zx is equal to 1, from which given tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2. Okay. So now let us write down the second given condition. So now what is the second given condition out here? Again, here given is, what is given? X plus y plus z is equal to root over 3. Right? So what is the second given part here? It is x plus y plus z is equal to root over 3. So let us eliminate square root from 3. That means you have to square both the sides. So let us write squaring both the sides. So squaring both the sides. Squaring both the sides, what do we get? X plus y plus z whole square is equal to, this is your root over 3 whole square, right? So you know this formula. You should know this formula, isn't it? So what is a plus b plus c whole square? A square plus b square plus c square plus twice ab plus twice bc plus twice ca, right? So similarly, in this case, instead of a there is x, instead of b there is y, instead of c there is z. So same formula may be used here. That is x square plus y square plus z square plus 2xy plus 2yz plus 2zx, which is equal to what? It is 3. Is that clear now? So I think you have understood it up to here. So now, how will you simplify it now? So from here, you have to prove x is equal to y is equal to z. So how will you do it? So now, there is only 3 here, isn't it? So left hand side is simplified. That is, we have written here the formulae. That is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx, which is equal to, what is root over 3 whole square? It is 3. But actually, this is 3 into 1, isn't it? Actually, 3 means 3 into 1. So instead of 1 here, from 1 we can write, instead of 1, what can you write? xy plus yz plus zx. Can you write it? So let us write it and let us simplify it, right? So now, this one now becomes, therefore, x square plus y square plus z square, then plus 2xy plus 2yz plus 2zx is equal to 3 within bracket. So instead of 1, what can you write? We can write it from this first condition, that is, instead of 1, what can you write? xy plus yz plus zx. So let us write it here. Instead of 1, you write xy plus yz plus zx. Okay? So let us simplify it. So, or this is x square plus y square plus z square plus 2xy plus 2yz plus 2zx is equal to, now multiply by 3 here, 3xy plus 3yz minus 3zx. Okay? Now let us take these terms which are on the right hand side to the left hand side. Okay? Your right hand side ma jun chai terms haru chan tyohru sabai lai hami kata lanchau, left patti lanchau, because 2xy 3xy can be simplified, 2yz 3yz can be simplified, sorry, this one is plus, and you can simplify 2zx and 3zx also, you can simplify them. Okay? So now you can take 3xy plus 3yz plus 3zx, which are on the right hand side, to the left hand side, so they become minus, isn't it? So, or x square plus y square plus z square. What is 2xy minus 3xy? Minus xy. What is 2yz minus 3yz? Minus yz. What is 2zx minus 3zx? Minus zx, which is equal to 0. Okay? So now, next, what will you do now? So from here, we can prove x is equal to y is equal to z. So how can you prove it? Okay? So you should convert it into the form of a minus b whole square. You know a minus b whole square, isn't it? It is a square minus 2ab plus b square. But here it is only xy. You should write here 2. This is only yz. You should write here 2yz. There is only zx. You should write here 2. Okay. That means you have to multiply both the sides by 2. First of all, you multiply both the sides by 2. So write down multiplying both the sides by 2 first. Right? Multiplying both the sides by 2. So what do we get? 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx is equal to, what is 0 to z? That is 0. Is that clear? Now in order to convert them into a square minus 2ab plus b square, for this minus 2xy we need x square y square, x square plus y square, isn't it? Also for minus 2yz we need y square plus z square, and also for 2zx we need z square plus x square. So where can we take that from? We can take that from this 2x square, 2y square, 2z square by writing them as x square plus x square, 2y square is y square plus y square, 2z square as z square plus z square. Is that clear now? So let us write it. What is 2x square here? X square plus x square. What is 2y square here? Y square plus y square. Plus, what is 2z square? It is z square plus z square, right? So then write down minus 2xy minus 2yz minus 2zx, which is equal to what? It is 0, right? So now for this minus 2xy, what do we need? We need x square and y square, right? For this minus 2yz, what do we need? Y square plus z square, y square plus z square are needed. And for this minus 2zx, we need the unmarked terms, isn't it? That is z square and x square. Okay? So now let us write these terms together. Okay? So or x square plus y square minus 2xy, let us write it within bracket, plus next what do we need? Cross marked terms, y square plus z square minus 2yz. Then write down the unmarked terms. Which are the unmarked terms here? Plus z square plus, next this is x square, and then minus 2zx bracket closed, which is equal to 0, right? Is that clear to all of you? So now you can use the formula out there. So what is the formula that you can use there? A square plus b square minus 2ab, which is equal to a minus b whole square. Okay? So or it is x minus y whole square plus this is y minus z whole square plus this one is z minus x whole square, which is equal to 0. Now all these left hand side is equal to 0. That means x minus y whole square, this whole square term plus this whole square term plus this whole square term is equal to 0. But you know that whatever may be the values of x and y, right? So x minus y, it may be positive, it may be negative, isn't it? X may be greater than y, x may be less than y. If x is greater than y, then it is positive. If y is greater than x, then it is negative. But because of this whole square, plus whole square, negative whole square is always plus. So this is a positive quantity. Similarly, y minus z whole square is also a positive quantity. Z minus x whole square is also a positive quantity. So positive quantity plus positive quantity plus positive quantity never equal to 0. They are never equal to 0. This summation quantity is never equal to 0. You kaile pani 0 cannot be equal to 0. This left hand side cannot be equal to 0 because all are positive terms out here. So this equation is possible only if x minus y is equal to 0, y minus z is equal to 0 and z minus x is equal to 0. all these individual values within whole square must be separately 0. This equation is possible. That is, this left hand side is equal to 0 if all the individual expression within whole square will be equal to 0. Is that clear? So now write down. So this equation now this equation is possible. This equation is possible only if individual values within whole square will be equal to 0. That is, x minus y is equal to 0 and y minus z is equal to 0 and z minus x is equal to 0. Is that clear now? So therefore, this is x is equal to y and this is y is equal to z and this z is equal to x. Is that clear? Now, if you combine all these three, that is x is equal to y and y is equal to z and z is equal to x, what do we get? That is, you will get, so if you combine all these three, that is x is equal to y and y is equal to z and z is equal to x, what do we get? X is equal to y is equal to z. That is proved. So I think you have understood it. So this question is very, very important and quite complicated also. So you can practice it at home. If you practice it at home, it will be more easier for you to do this problem. Okay. So now let's do the next question. So you can copy it. So now we will do question from part B section. That is, it is of multiple choice question type, and you have to answer this question in this question paper itself. Okay, this is known as question com answer booklet. This is your part B. You have to write down the answers here only. Okay, you have to write down the answers here. There is the blank box out there. You have to write there the correct option. That is, the box will be provided like this. If A is correct, if among these four options A, B, C, D, if A is correct, you have to write A out here. Okay, but don't write down the answer here. Suppose A is correct, so his answer is pi, so don't write pi here, you have to write A. So I'll read out the instruction from here. So you should know this instruction also, because you have to write down the question in this question com answer booklet. Okay, so instruction to candidates. Number 1, the candidate is required to write his her full name, roll number and registration number on the question com answer booklet according to the admit card issued by the council. If it is wrongly written, the question com answer booklet may be rejected. Okay, so it is compulsory for the examinee to get the question com answer booklet signed by the invigilator in the space provided. So number 2 is, a box is provided at the right side bottom against each question of MCQ, that is multiple choice question, for both these versions. You must write down the correct choice A, B, C or D in this box. So number 3 is, after completion of the examination, this question com answer booklet should be tied securely with the main answer script. Okay, त यसमा चाहिँ के भन्दैछ भन्दाखेरि तिमीले यो जुन चाहिँ मल्टिपल चोइस क्वेशन छ पार्ट बी, यो पार्ट बी को आन्सर तिमीले यो क्वेशन पेपरमा नै लेख्नु पर्ने छ। अनि यो क्वेशन पेपरमा तिमीको नाम, रोल नम्बर ठीकसँग लेख्नु पर्यो, रेजिस्ट्रेसन नम्बर पनि लेख्नु पर्छ, अनि इट शुड बी साइन्ड बाइ द इन्भिजिलेटर्स। बुझ्यो? त कुनै पनि इन्भिजिलेटरले तिमीको पार्ट बी मा सिग्नेचर गरेको छैन भने तिमीले सिग्नेचर गर्न लाउने। ठीक छ? को बेला बिर्सिनु सक्छ बाइ मिस्टेक, हैन? त्यही त यहाँ सिग्नेचर अफ द इन्भिजिलेटर भनेको चाहिँ यहाँ सिग्नेचर गराउने। ठीक छ? सो अब हामी एन्सर गर्दा फेरि अब यसलाई हामी चेक गर्नु पर्यो यसको लागि एक्स्ट्रा पेपर चाहियो एक्स्ट्रा पेपर तिमीलाई माग्दा दिइदैन बुझ्यो एक्जामिनरले जो चाहिँ तिमीहरुको इन्भिजिलेटर हुन्छन् क्लासमा उनीहरुले तिमीहरुलाई फाल्टो पेपर दिदैनन् ठीक छ त तिमीहरुको यो जुन चाहिँ यो क्वेशन कम आन्सर बुकलेट छ नि त्यसको लास्ट पेजमा नि यहाँ एक्स्ट्रा पेज फर एनी क्याल्कुलेसन इफ निडेड भनेको हुन्छ यही तिमीले रफ वर्क गर्दा नि भयो कि त मेन आन्सर स्क्रिनमा रफ वर्क गर्दा पनि हुन्छ बुझ्यो बुझेन त तिमीले फाल्टो पेपर चाहिँ चलाउन एकदमै पाउँदैनौ ठीक छ अनि त्यहाँदेखि तिमीलाई अब अघि नै मैले भने सपोज 1 को 4 को आन्सर गर्दैछु तिमीले हैन अब यहाँ चेक गर्नु पर्यो रफ वर्कमा गर्छ कुन चाहिँ करेक्ट अब ए बी सी डी मा ए करेक्ट आयो भने ए नै लेख्नु त्यहाँ डोन्ट राइट डाउन द आन्सर राइट अनि यो क्वेशन पेपर गरिसकेपछि यो जुन चाहिँ क्वेशन कम आन्सर बुकलेट छ यो तिमीले कम्प्लिट गरिसकेपछि अनि लास्टमा तिमीले जुन चाहिँ आन्सर स्क्रिप्ट बुझाउँछौ त्यो मेन आन्सर स्क्रिप्ट भित्रपटि यो तिमीले मज्जाले सिक्युरली यो एउटा थ्रेडले बाँडिदिनु मेन आन्सर स्क्रिप्टसँग बुझ्यौ त यो चाहिँ तिमीले बिर्सिनु हुँदैन त यदि यो तिमीले बाँड्नु बिर्स्यौ र तिमीले घरमा लग्यौ भने त्यो अलिकति मुस्किलै पर्छ बुझ्नु छैन त्यो अलिक राम्रो हुँदैन त्यति बेला चाहिँ बुझ्नु छैन यो चाहिँ राम्रोसँग याद राखिराख्नु बुझ्यौ तिमीले सबैले यो पार्ट बी को क्वेशन्स को आन्सर चाहिँ तिमीले यही क्वेशन पेपर भित्रमै गर्नुपर्छ ठीक छ मैले देखाउँदैछु जस्तै एक्जाम्पल यहाँ है जस्तै यो क्वेशन 1 नम्बर 6 हो यो इंग्लिश भर्सन भयो ए बी सी डी यहाँ चाहिँ तिमीले करेक्ट अप्सन भन्नु पर्यो ठीक छ So now let's do it. So this question is from HS 2016. This question is 1 number 4. Each question carry only 1 mark. Each question carries only 1 mark. Okay. If sec inverse x is equal to cos inverse y, it is given. Then the value of cos inverse 1 upon x plus cos inverse 1 upon y will be what? A, B, C or D. यो चारटामा एउटा अप्सन मात्रै करेक्ट हुन्छ त्यो अप्सन चाहिँ तिमीले त्यहाँ लेख्नु पर्छ ठीक छ So here given is what is given here? It is sec inverse x is equal to cosec inverse y. त यसलाई हामी केमा चेन्ज गर्छौं भन्दा फेरि यसलाई हामीले चेन्ज गर्नु पर्यो in terms of sec inverse x should be changed into cos inverse and cosec inverse should be changed into sin inverse. So or what is it? Cos inverse 1 upon x is equal to this is sin inverse 1 upon y. All right? The key value निकाल्नु पर्छ तिमीले therefore given expression is what? Cos inverse 1 upon x plus cos inverse 1 upon y, which is equal to. So instead of cos inverse 1 upon x, what can you write? Sin inverse 1 upon y. Let us write here sin inverse 1 upon y plus cos inverse 1 upon y. Okay. So both must be the same expression here. 1 upon y, 1 upon y. It is just like a sin inverse x plus cos inverse x, which is equal to pi by 2. Similarly, what is sin inverse 1 upon y plus cos inverse 1 upon y? It is equal to pi by 2. So which is the correct option out here? A, B, C or D? D. So D is the correct option. Don't write pi by 2 here. You have to write the correct option, that is D. Is that clear? The university value question paper that is D. This is your D option is correct. That is pi by 2. So let's do the next question now. So now let's do this question. This is from HS 2017, right? The question is this is of part B. This is in part B question. That is question come answer booklet. That is MCQ type. So 1 number 5 is the value of sine of cos inverse x minus cos of sine inverse x is A, B, C or D. Which one is correct? You have to check it. A is 1, B is x, C is 1 by x and D is 0. So you have to check which one is correct, right? So sine within bracket cos inverse x minus cos within bracket this is sine inverse x. Now let us simplify it now. So how can we simplify it further? Since this is sine, you have to convert it to sine inverse. You know how to convert this cos inverse x into sine inverse, isn't it? This is cos, you have to change sine inverse into cos inverse, right? So is equal to sine, let us change this cos inverse into sine inverse. So it is sine inverse root over 1 minus x square minus cos of, how can we change sine inverse x into cos inverse? Similarly, you can write here, it is cos inverse root over 1 minus x square. Is that clear to all of you? So what is sine inverse x? It is x. So it is only, you have to write only root over 1 minus x square minus, what is cos inverse root over 1 minus x square? Cos inverse will be cancelled. So what do we get? Root over 1 minus x square. Both of these will be cancelled, which is equal to 0. So 0 is the answer. So which is the correct option? A, B, C or D? Which is the correct option? Oh, it is D. So you should write here D option. Is that clear? Now let's do the next question. So now we will do question from Higher Secondary 2018 Part B MCQ type. This question also carries 1 mark. That is 1 number 7 is the question number. The principal value of tan inverse within bracket minus root over 3 is what? A, B, C or D? Which one is the correct option? So we did principal values from the book, isn't it? You know how to find out the principal value. Principal values means you have to get the least value of the given inverse circular function, right? So it is given tan inverse minus root over 3. So since this is tan inverse, you should write this minus root over 3 in terms of tan. Tan of which angle is minus root 3? So since this is negative, tan is negative in the 4th quadrant, you can write down the angle in the 4th quadrant also, isn't it? So which is equal to tan inverse, tan of which angle is minus root 3? If you write only pi by 3, if you write only tan 60, it will be root 3. But it is negative given out here, so you should write here minus, right? So now, what is tan of minus pi by 3? Minus tan pi by 3, that is minus tan 60 degree, which is equal to root over 3, okay? So, is equal to, what is tan inverse tan theta? Theta, that means minus pi by 3. So, minus pi by 3 is the correct answer out here. So which is the correct option now here? It is minus pi by 3. That is minus 60 degree or minus pi by 3. Which is the correct option? It is D. Understood now? So we'll do the next question again from HS 2019, right? And now we will do question from Higher Secondary 2019. This is Part B MCQ type, multiple choice question type. So this question also carries 1 mark. Okay, the question is HS 2019 1 number 6. The value of tan within bracket pi by 2 minus tan inverse 1/3 is equal to A, B, C or D. Which one is correct? You have to write it. Okay. So therefore, what is given here? Tan pi by 2 minus tan inverse 1/3, right? Let us take it as theta. Tan inverse 1 by 3, let us take it as theta. So this is tan 90 minus theta. What is tan 90 minus theta? You know that it is cot theta. So which is equal to cot. What is theta here? It is tan inverse 1/3, right? So since this is cot, you should convert tan inverse into cot inverse. So is equal to cot within bracket. What do we write? It is cot inverse 3 because tan inverse 1/3 is cot inverse 3. So what is cot of cot inverse 3? Which is equal to 3. So 3 is the answer. So which is the correct option here? It is B. So you should write here B. So B option is correct. Is that clear? So let's do next question now. Now we will do question from HS 2020 this year. This is from Part B again, multiple choice question type. This question also carries 1 mark, right? So this is also principal value. You have to find out the principal value. The principal value of sine inverse sine of 5 pi by 6 is sine inverse sine of 5 pi by 6 is what? If you directly write 5 pi by 6, it may be wrong. It may be correct, it may be wrong, we don't know. Suppose you don't know, right? So let's, what will you do here? Let's simplify. Let's find out the value for sine 5 pi by 6, alright? So which is equal to sine inverse sine, what is pi by 6? It is 30 into 5. What is pi by 6? It is 30, isn't it? 30 degree into 5. It is 150 degree, right? Is equal to, let us find out its value. How to write it? Sine 180 degree minus what? 30 degree. You know that sine 180 minus theta is sine theta. That is 180 minus 30 is also 150. So instead of 150, what do we write? 180 degree minus 30 degree. You can find out its value. Is equal to sine inverse within bracket. What is sine 180 minus theta? It lies in the second quadrant. In the second quadrant, sine is always positive. So usually we don't write positive sign. 180 is even multiple of 90. So sine remains same. That is sine 30 degree. Right? Now what is sine 30 degree? Sine 30 degree is 1 upon 2. But since in this case you have to find out the principal value. That is the least value. So this is the positive value, half. Now sine of which angle is half in the first quadrant? That is 30 degree, isn't it? So which is equal to sine inverse sine of 30 degree. So how can you write 30 degree in terms of radian? It is pi by 6. So it is pi by 6, which is equal to, what is the answer? What is the principal value of this given expression? Sine inverse sine of 5 pi by 6. What is the principal value of sine inverse sine 5 pi by 6? It is only pi by 6. So which is the correct option? It is pi by 6, but not 5 pi by 6. Is that clear? So which is the correct option? It is A, that is pi by 6. So A is the correct option out here. So I think you have understood it. Okay, so you can copy it. So you revise all the problems that we did today. Okay, so this chapter, inverse circular function, is finished. Okay, so in the next class we will do determinant, that is application of determinant. We have finished the problems. Now we will do application of determinant, that is how to solve given three linear equations with the help of determinant, that is known as Cramer's rule. And also the application of determinant is you have to find out the area of the triangle using determinant. So application of determinant is number one is you have to solve three equations with three unknowns or two equations with two unknowns with the help of Cramer's rule. That is the first application of determinant. And another application of determinant is to find out the area of the triangle using determinant. So in the next class we will do this application of determinant. Okay, so this much is for today.